In this module, we'll see how we can perform different standard I/O operations using bash scripts. The first chapter is the redirection in a file. Let's add a command called ls-l in our script and execute it. When you execute this script, the output is printed into standard I/O. Let's say we want to redirect this output to one of the file, myout.txt. So the operator would be ls-l redirection operator myout.txt. When you save and execute this, there will be no output in the stdio. All output is written into the file called myout.txt. Let's say we want to append more statements to our same log file, echo more logs. And the append operator is double redirection myout.txt. When you execute it, in the log file you see the echo statement is appended to the log file. So if you don't give double redirection operator in case of second statements onwards, the file would be overwritten each time we execute any kind of redirection operation. In this way, you can use this feature for logging. In the future lecture, we'll see how we can use logging feature in bash scripting effectively. That's all about redirection. In the next lecture, we'll see standard input operations.
Standard I/O. What do what do the terms standard input, standard output, and standard error mean?
A process has a single way of taking input, that is the standard input, which is by default is the keyboard through the terminal. It also has a way of showing the output to standard output and standard error, which is by default the screen or terminal. For use in scripting, they have been assigned different default numbers to the standard input or standard output or standard error. For standard input, the file descriptor is 0 and default by a keyboard. For standard output, the file descriptor is 1, default is screen. And for standard error, the file descriptor is 2 and the default is via screen. Let's open a file called stdio.sh, add echo $1, $2. Then save the script and execute with the different parameters like foo and var. So here we see it prints foo and var. So in the script we have given two parameters foo and var. These are interpreted by $1 and $2. In this way you can take n number of arguments to the script. So what is $0 then? Let's print echo $0. When you execute it, stdio.sh foo var myvar. Here you see the value of $0 is the script itself. The value of the $0 is the script itself. Instead of taking all the arguments as $1, $2, $3, we can take all the arguments in the form of an array as equal to $echo. So here we can take all the arguments in the form of an array. We're taking as $, which is the array we'll be getting, and printing the values of that array. When you execute stdio.sh with different parameters like foo and var, here we see the array is printed. So now don't worry about the array, we'll discuss in future. All the arguments, no matter how many number of elements you are providing via the script using echo $. Via echo $, we are printing all the arguments. Let's say you want to know how many number of arguments are passed via command line to the script, so that you can use it inside the script for validation purposes. To do that, type echo $hash. Execute the same script. You'll see we have passed 3 arguments to the script. Thus, we can use this echo $hash statement for number of arguments provided to the script for validation. That's all about input arguments. Let's see how we can read a file using this argument. In this script, we're taking the argument as a standard in from the $1 from standard in. If we give a file name as a parameter to the script, then it will read the entire contents of the file. Let's try to execute the script using stdio underscore file.sh, and we'll give a file name as parameter foo.txt. The entire file contents is read by this script. Let's see how you can read a variable from the standard in. Let's open the same script called stdio.sh. To read a variable from the standard in, you need the command read, then that variable name. So our script will wait for the standard in to enter the variable name. Similarly, we're reading another variable called lname, and we're just printing the values of those variables. Let's try to execute the script stdio.sh. So it is asking us for the input from the command line. Let's enter Zane. So it read both the variables called first name and last name and printed as per the input. In this way, you can take inputs from standard in into variables directly. That's all about standard in. In the next lecture, we'll see how you can use standard out and standard error.
Standard output. There's two components, standard out and standard error. All the output from a file or command would be redirected to standard out, and all errors will be redirected to standard error.
Let's see how we can implement this using scripts. Let's write two commands, ls-l, which is the correct command, and lsl-l, which is the incorrect command. The output of the correct command will be printed on standard out, and output of the incorrect command will be printed on standard error. Let's execute the script. The correct command output is printed here, and this is the output of the incorrect command. So how we can distinguish between this std out and std error, as we are seeing both on the command lines? This can be done using redirection, and let's see how we can redirect it. As we have discussed earlier, for standard out the descriptor is 1, so 1 redirect to file.txt, and for standard error the descriptor is 2, so the file redirection will be file.error, 2 greater than file.error. Let's try to execute it. Here we'll see no output in the terminal, but two files are created called file.txt, which contains the output of the ls-l command, that is the standard out, and another file called file.error, which contains the output of the incorrect command. In this way, we can separate the std out and std error to different files. So here nothing is specific to extension. You can add any kind of extension to a file while redirection. You can also give instruction to print both std out and std error to a single file. We have another file called, let's create another file std out underscore single with these two commands. One is successful, another is wrong command. In our existing stdout.sh, we'll call this script for execution using bash stdout.single.sh, and we'll try to redirect both stdout and std error to a single file using greater than file.out, then 2 greater than &1. So here both stdout as well as std error will be redirected to this file called file.out. Let's try to execute the script. So no output is printed in the terminal. Let's check this file.out. The file.out contains both stdout as well as std error. In this way, we can redirect both stdout and std error to a single file. So that's all about standard out and standard error. In the next lecture, we'll see how we can communicate between two scripts. In this lecture, we'll see how we can communicate between two scripts. What we'll do here, we'll create a variable in one of the script and try to send that value to another script so that second script can use that variable while executing. Let's switch over to our terminal. Create a script called fast_script.sh. Here we'll define a variable called myloc equal to plus home. Earlier we have seen how we can export a variable from one script so that other scripts or other cell can reuse that. We'll do that by using export myloc. In our second script will be sourcing the fast script as source fast_script.sh so that the fast script is included in this script, and our variable myloc, I'm trying to just print this variable myloc. Let's execute the script. Here we can see /home is printed. In this communicate.sh, we haven't defined any variable called myloc, but it can print the value of the myloc because it can get the variable from another script. In this way, we can communicate between two different scripts using source and export. That's all about communication between scripts. This brings to the closure of this module. Let's summarize what we have learned in this module. In this module, we have learned how to redirect to different files, how we can take standard input from the terminal, as well as read different arguments to a script and process those arguments. Then we took a look into standard output and standard error, as well as their redirection. And finally, how we can communicate between different scripts. That's all about this module. In the next module, we'll see some more features about bash scripting.